aqui na minha idade que irei falar em português, até porque a maior parte dos portugueses são portugueses e para os ingleses eu tenho a minha apresentação em inglês, não é? Pode ser? Tem que ser. Também vou pedir desculpa porque já percebi que o layout da minha apresentação está muito antiquado relativamente aos outros layouts que são espetaculares, mas na próxima eu ainda estou em idade de aprender e, portanto, irei atualizar o layout da minha apresentação. Eu vou falar um bocadinho sobre a experiência da licenciatura em Engenharia Civil do ISEP na implementação de estágios. Podem achar que não é novidade nenhuma e que a maior parte dos cursos de engenharia já têm estágios no seu percurso académico. Mas ao nível do primeiro ciclo, ao nível da licenciatura, efetivamente, na área de engenharia civil, é uma novidade e a maior parte das nossas formações e das nossas escolas superiores não têm estágios ao nível do primeiro ciclo. Então, aqui é a estrutura da minha apresentação. Sabemos que o ensino politécnico tem algumas especificidades próprias, nomeadamente na aplicação do conhecimento, e nós, no Decreto-Lei 74 de 2006, evidencia na lei portuguesa a importância de uma componente de aplicação prática do conhecimento. Para responder a este desafio, a direção da licenciatura em Engenharia Civil, onde eu me integro, resolveu começar a promover então a realização de pequenos estágios, nós chamamos antes trabalhos em ambiente empresarial, através da unidade curricular de projetos integrados. Então, também para motivar o interesse na área da engenharia civil, que, como sabem, há alguns anos atrás tivemos um decréscimo significativo do número de estudantes nesta área, nós começamos também a procurar que ao longo do caminho do percurso académico dos nossos estudantes a engenharia civil fosse focado em cada uma das unidades curriculares e este processo termina com o projeto integrado no último semestre dos nossos alunos, em que eles irão procurar resolver um projeto, um problema em que aplicarão os conhecimentos adquiridos ao longo do seu percurso escolar. Só por curiosidade também, em 2020 e 2021, a equipa de coordenação da licenciatura em Engenharia Civil e também do mestrado em Engenharia Civil do ISEP promoveu o primeiro simpósio de Engenharia Civil, conhecido por CEP de 2021. Não sei se alguém fez parte da organização também deste simpósio. Portanto, foi um simpósio em que nós conseguimos juntar todas as escolas superiores onde lecionam Engenharia Civil, cerca de 12 politécnicos e 16 universidades, e percebemos que neste simpósio, vou mostrar a imagem do nosso simpósio, este ano já houve um CEP 2023 que foi promovido pelo Instituto Superior Técnico, e nós percebemos neste simpósio que, efetivamente, a licenciatura em Engenharia Civil do ISEP é a pioneira na implementação dos estágios ao nível do primeiro ciclo. Penso que mais nenhuma escola estaria a fazer naquele momento e, portanto, éramos pioneiros nestes trabalhos em ambiente empresarial. O principal objetivo desta unidade curricular do projeto integrado, é o desenvolvimento de um problema prático tão próximo quanto possível daqueles que um dia mais tarde os nossos estudantes irão encontrar na sua atividade profissional. Então, para além do trabalho que eles têm de desenvolver, também devem desenvolver e adquirir uma série de competências ao nível da capacidade de trabalho autónomo, trabalho de grupo, trabalho individual, escrever um relatório, que tem muitas dificuldades, e depois uma apresentação pública perante um júri e uma discussão pública do seu trabalho. Os principais objetivos desta unidade curricular serão desenvolver uma metodologia de ensino fortemente baseada numa componente prática, também fomentar competências de trabalho de grupo, motivar os nossos estudantes para a engenharia civil e promover a empregabilidade e a competitividade dos nossos licenciados. E também estabelecer um conjunto de protocolos com empresas que habitualmente trabalham connosco. Nesta unidade curricular, os estudantes têm duas hipóteses: ou fazem um trabalho de grupo que é orientado com um professor do ISEP, ou fazem um trabalho individual então numa empresa em que tem orientação do docente do ISEP e a orientação do profissional, do engenheiro sénior da empresa. Esta última hipótese, estes tais pequenos estágios, estes trabalhos em ambiente empresarial, só foram possíveis a partir do ano letivo 2015-2016. O regulamento desta unidade curricular está publicado no Google. Os estudantes tomam conhecimento do modo de funcionamento da unidade curricular através de uma reunião que nós todos os anos promovemos em que estão presentes também antigos alunos e empresas que colaboram connosco, que explicam as regras e nós também explicamos as regras de funcionamento desta unidade curricular. E também nesta reunião nós atribuímos prémios aos melhores trabalhos dos anos letivos anteriores. Nesta reunião são indicados quais são os temas para os estágios e os temas para os trabalhos a desenvolver no ISEP. Segue-se um processo de seleção em que os estudantes indicam 3 projetos de ordem de preferência. Eles depois é feito um ranking em função das suas notas, das suas classificações em 8 unidades curriculares e também o seu desempenho numa entrevista com os membros da equipa coordenadora da licenciatura em Engenharia Civil. Nos estágios, eles devem estar cerca de 10 horas por semana nas empresas, cerca de 2 tardes por semana, e têm então a supervisão de um professor do ISEP e de um orientador por parte do engenheiro da empresa. Também durante o semestre, a equipa coordenadora do LEC promove 3 pequenas ações de formação, uma sobre referências bibliográficas, outra sobre como apresentar e como fazer e estruturar uma apresentação pública e depois um curso de MS Word avançado para os ajudar na elaboração do seu relatório final. Para a seleção das empresas que colaboram connosco, escolhemos empresas que tenham uma equipa técnica capaz de acolher os nossos alunos, que permitam também a definição de temas interessantes para os nossos alunos, que sejam disponíveis para receber estudantes em part-time e que, sempre que possível, tentamos manter as empresas que já trabalham connosco e tiveram experiências bem-sucedidas. No ano que nós começamos esta experiência de estágio em 2015-2016, apenas com 3 estudantes e 3 empresas, e temos vindo ao longo do tempo a alargar o número de estudantes que podem fazer estágio e este processo tem vindo a ser feito de uma forma muito gradual e tentamos que seja de uma forma muito consolidada. Atualmente, já mais de metade dos nossos estudantes nesta unidade curricular fazem o seu estágio numa empresa. Então, como podem ver, começamos em 2015-2016 com apenas 3 estágios e 3 empresas e tínhamos um total de 74 alunos. Também aqui é interessante ver a diminuição dos alunos na área da engenharia civil, que foi notório no país. Agora já recuperamos, preenchemos as vagas todas. No ano letivo anterior, nós tínhamos 55 estudantes nesta unidade curricular, dos quais 29 estavam a desenvolver estágios. No primeiro ano da pandemia, 2019-2020, pela primeira vez o número de estágios excedeu o número de trabalhos realizados no ISEP. No entanto, destes 27 trabalhos propostos nas empresas, apenas foi possível, devido à pandemia, realizar 13. Isto é a evolução e ali o período da pandemia representado. Portanto, atualmente, no ano letivo anterior, tínhamos 25 empresas e 29 estágios. Isto é o nosso Wall of Fame, não é? As empresas que habitualmente colaboram connosco. Motengil, Águas do Porto, a REN, o próprio Politécnico do Porto também trabalha connosco. Como é que é feita a avaliação dos nossos estudantes, nomeadamente os que estão em estágio? A sua performance, portanto, o seu desempenho durante o período académico e o seu desempenho nas provas públicas. No final do semestre, eles têm que submeter no portal um relatório final que será depois também avaliado. Então, durante o período letivo, avaliamos a presença dos alunos nas reuniões periódicas e o seu contributo, a sua motivação, a sua capacidade de trabalho e a sua autonomia para desenvolver o trabalho que lhe é proposto. Na prova pública, eles apresentam fazem uma pequena apresentação, seguida de uma discussão com um júri e depois segue-se uma reunião dos elementos do júri que, de acordo com uma grelha proposta por nós, é feita a classificação de cada um dos estudantes. Nessa grelha, nós pontuamos entre 0 e 4 os seguintes parâmetros, nomeadamente o nível de dificuldade, a autonomia do estudante, o atingir ou ultrapassar os objetivos propostos, a qualidade do relatório escrito e também o desempenho nas provas públicas. Isto é um exemplo de uma grelha, de uma classificação, que se nós somarmos as notas em cada uma, os pontos em cada um destes 5 itens, obtemos a classificação final. Como é que funcionou durante o Covid? Funcionou essencialmente através de reuniões pelo Zoom e trabalhos pelo Zoom. Como sabem, a construção civil não parou durante o período da pandemia, portanto, alguns alunos tiveram a hipótese ainda de ir às empresas mesmo no período da pandemia. No primeiro ano, a unidade curricular já estava a funcionar, portanto, não houve problema na distribuição dos trabalhos. Nos anos seguintes, houve a necessidade de promover as reuniões de apresentação da unidade curricular através do Zoom. Isto que eu já expliquei, que atualmente nós já temos mais de metade dos estudantes a fazerem o seu trabalho em ambiente empresarial. Portanto, durante os primeiros anos da pandemia, o que aconteceu é que as reuniões eram essencialmente pelo Zoom e hoje em dia continuamos a utilizar muitas vezes reuniões pelo Zoom, nomeadamente para os alunos, trabalhadores e estudantes. Nós temos vindo a monitorizar a implementação destes estágios através da análise das classificações, das taxas de sucesso, do interesse dos alunos em candidatarem-se a estes estágios e na opinião dos supervisores. Em termos de classificação, são muito próximas da classificação global nesta unidade curricular. Em termos de taxa de aprovação, também são geralmente superiores à taxa de aprovação global desta unidade curricular e mais de 60% dos estudantes candidatam-se aos estágios. Também durante o semestre nós vamos avaliando a opinião dos docentes e dos engenheiros das empresas, que são muito favoráveis a esta iniciativa, mostram-se disponíveis para orientar os alunos e a única coisa que nos apontam é que o tempo de permanência nas empresas deveria ser aumentado. Então, como conclusões, nós devemos estender estes estágios à maioria dos nossos estudantes. Pensamos que todos os envolvidos estão satisfeitos com esta iniciativa e devemos também procurar que o tempo de permanência dos nossos estudantes nas empresas seja aumentado. Aquilo que nos move, e se nos moverá sempre, será
Obrigada pela apresentação, foi interessante. Primeiro queria só um esclarecimento que eu não sei se percebi. Pareceu que a certa altura disse que os estudantes podiam escolher entre fazer um projeto individual ou fazer um trabalho em grupo.
o trabalho em grupo é feito no ISEP, não é os...
Mas todos fazem as duas modalidades?
Não, tem que escolher uma. Pronto,
A minha questão então...
estágios para todos.
Sim. A minha questão então é que pareceu que um dos objetivos de estudar é que todos desenvolvam competências de trabalho em equipa.
Sim.
Se há alunos que só fazem trabalho individual, como é que essas competências são
Mas aí a equipa
desenvolvidas?
passa a ser empresa. Portanto, eles são integrados por empresa. Portanto, a equipa passa a ser a equipa da empresa.
Mas então, se calhar eu não percebi. Os que fazem no ISEP fazem em grupo?
Fazem grupo de 2, mas estão no ISEP orientados por nós.
Sim. E os que estão na empresa consideram que é a empresa?
Não podia, porque eles não podiam ir em grupo para a empresa. Não faz sentido.
Queria parabenizar pela apresentação.
Obrigada.
Porque queria lançar uma pergunta aqui para você, que é do ISEP, né?
Sim.
Porque uma coisa que me preocupa muito é que eu comparo com a medicina, por exemplo, pelo menos no Brasil, só existe um curso de medicina se tiver um hospital. Se não tem hospital, não tem curso de medicina. Né? E a engenharia...
Também devia ser um bocadinho assim.
Eu noto que o estágio, muitas vezes lá, pelo menos, e muitas vezes ele é meio pro forma, assim, o aluno já trabalha em uma empresa, então já faz o estágio naquela empresa que ele trabalha. Eu vi que ali são 10 horas por semana e tal, então existe algum movimento no sentido de fazer uma vinculação mais forte dos cursos com o mundo do trabalho, né?
Sim. No ISEP, e está aqui o Gustavo, no ISEP, o Gustavo estava distraído, mas no ISEP a maioria das nossas licenciaturas já tinham estágio. Penso que só a licenciatura em Engenharia Geotécnica é que não tem estágio. E a Engenharia Civil também não tinha. Mas a maior parte das licenciaturas já tinham estágio no...
E eles fazem a aula concomitante do estágio ou fazem uma imersão?
Têm aulas e estágio simultaneamente.
Eu acho que melhor seria uma imersão de estágio, né? Medicina
Pois, é isso que nós estamos a tentar, que é aumentar o tempo de permanência no estágio, porque 10 horas por semana é muito pouco. É muito pouco, portanto, é esse agora o nosso objetivo, é aumentar o número de horas de permanência nos estágios.
Obrigado.
A minha pergunta vinha relativamente a isto, que é quantas cadeiras é que os alunos têm simultâneo ao estágio?
São 5 unidades curriculares, com o estágio, portanto 4 mais o projeto integrado.
Se calhar explicou-nos se passou e não perceber. Como é que é feita a seleção? De quem fica a fazer trabalho de grupo e quem é que vai para a
Assim, primeiro nós lançamos os esquemas dos estágios. E quem está interessado, candidata-se aos estágios. A maioria estão todos interessados nos estágios, mas nós não temos para todos. Nós também temos uma componente muito grande de alunos trabalhadores estudantes. Os alunos trabalhadores estudantes não têm hipótese, por eles próprios, de se candidatarem no estágio, porque eles trabalham durante o dia. Portanto, esses, à partida, não vão querer os estágios. Por isso, aquela porcentagem que eu apresentei, se não considerasse os trabalhadores estudantes, era muito superior. Porque a maioria dos estudantes, digo, ordinários, quer fazer os estágios. Eles candidatam-se aos estágios, mas como não temos estágios para todos, aqueles que ou não podem, que são trabalhadores estudantes, ou não foram selecionados, porque não temos para todos.
Mas como é que é feita essa
A seriação, então, essa seriação, eles indicam 3 estágios por ordem de preferência.
Não, como é que escolhe o aluno?
Sim, eles indicam os 3 estágios por ordem de preferência e nós temos as 8 notas em 8 unidades curriculares, fazemos a média e depois fazemos uma entrevista. E fazemos a seriação.
Muito obrigada.
The next speaker is Silva, and it will represent the investigation of effectiveness as a process control didactic skills in engineering education. So, please, 10 minutes.
Hi everyone, my name is Vinicius Silva and I'm here to present this following work. Some of the contents of this presentation, I'll start with some introduction and scope, describe the curricular unit, the educational kits used, the task, the data collection and tool description, and some final remarks. So the initial idea is we have a subject called process control and feedback control systems. They are the core of many engineering programs. So with the lower cost and design of educational kits that students can explore, we decided to select one to then for the students to work during the curricular unity. The kits can increase the students' engagement and by transforming their learning to be more interactive as students can see the results of the work in real time. So the main goal of this work was to evaluate the impact of incorporating these educational kits, focusing on how this approach can contribute to the development of problem solving and critical thinking. So more about the curricular unit. Process control, it's a curricular unit that focuses on industrial process and to control them effectively. It's mandatory and it's on the Masters in Mechanical Engineering. It emphasizes the importance of practical skills and problem solving, and thus employing these educational kits can be valuable. The TC Lab kit, it's a temperature control lab. Essentially, it's an Arduino Uno with an expansion board with 2 main heaters and temperature sensors to implement then feedback control algorithms. For the reasons to select this kit, it's supplied and completely assembled and ready to use. It can be programmed using Python. It's an open source project, and also MATLAB and Simulink. Also, this was already being employed in other works in the literature, so this was one more key advantage. The main task involves implementing the PID controller in this kit and analyzing its performance. The first step is to define the input, output, and the block diagram of the system, determine the transfer function. This is more control theory for who is here. Program the PID control, the proportional derivative and integral gains, and evaluate the performance of this controller in 4 main tests. So to evaluate the advantage of using these educational kits, a data collection tool was used, mainly online questionnaires. That was designed in order to gather the students' reaction regarding using this educational kits. So one of the several steps were included in the questionnaire. First, students' characterization, skills acquired, development / study of the kits, task accomplishment with the use of the kits, students' behavior during the use of the kits, and some final opinion of the students, open comments of the students. Student characterization. Here, from the 66 students in the curriculum unit, only 43% of them answered this online questionnaire. Out of them, 18% were female, 82 were male. Time spent on the activity per hour, 4% spent less than an hour per week, 32 up to 2 hours, and 28% up to 3 hours. They mostly prefer working at home, and 25 work in the university campus. With this, the students answer this first part, which is to characterize their learning style. By essentially identifying the process, if they learn by doing or by watching, or if they are more practical, they like more practical with real-world applications, so concrete, or more theoretical abstract. And this chart was created, and the main behavior that was classified is converging, which is typical of engineering students. They tend to like more active ways to learn. The majority of the students, 93%, identified that the educational kits allowed them to better understand the concepts of the study, under study, despite the difficulties that they encountered, 57%. Student skills acquired and accomplishments. The study of the students' acquired skills were based on a set of 7 keywords: self-learning, autonomy, understanding of the PID controllers, knowledge of the control parameters of PID, initiative, programming PID controls, and problem solving. Most of them, the majority, classified as, for example, understanding PID controls and autonomy above 4. And for the same classes, 2 aspects were evaluated: the relevant and most developed. For students' skills acquired and accomplishments, 13 aspects were evaluated. For example, if this work encouraged collaborative working, stimulated his or her intellectual curiosity, increased the ability to perform autonomous work, and to turn initiative. Most of them, more than 50% in all of, the majority of the aspects were above 4. However, some, for example, A7, which was defined as if improved my participation in class, was below 4. Students' achievements. 3 main statements were shown to the students. The first one, the various kits used reflect well the various concepts to be acquired in the course, the controllers. The second one, the use of the kits allowed a better understanding of the contents of the course. And the final one, I recommend the continued use of these kits, teaching / learning tool. Most of them agreed with the maximum rate. We had some outliers, namely like 3 students. Some of the final opinions, more open comments of the students. They handling the equipment that resembles the real thing in many ways. It was a positive aspect. Visualize the physical response of the kit to the code programmed by the group. This was in real time. It allowed me to effectively improve the development of my study and stimulate the execution of practical tasks. More on the negative, perhaps, the programming language background is needed, and more contact time with the kids is needed. Some final remarks. The present study can be considered a successful one towards the students' understanding of the topics in the scope of process control in a more practical way and nears to the real-world situations. The positive outcome of this study suggests that similar approach can be beneficial in other engineering fields and may help to bridge the gap between academic knowledge and practical skills required in the workforce. So thank you for your attention.
Yes.
First of all, congratulations for your presentation. This didactical kit is provided to every student or to a group of students?
It's a group of students, 2 students.
Okay. When you were writing your papers, have you considered the possibility to use the expression pocket law? And if so, why did you choose didactical kit?
This was we acquired this educational kits, and they were marked as educational kits dynamic.
This is marketing.
So we didn't develop them, so we maintained the same language.
Because actually, the students are supposed to take and be sure that 73% of the students refer that they have used this at home.
Yeah.
So basically, they take the
They take it home,
yeah, with them. So that's why. Yeah. So that's why the expression.
Could be, but it's, they also need to plug in out because the Arduino doesn't have the power enough for the heater, so there's an additional power supply, so it's not so much pocketable. But I understand the.
Very interesting. Pardon my ignorance because it's not my field, but I'm wondering, would Raspberry Pi have been an option for creating kits?
Yeah, could be, but it's very overpowered. Arduino Uno is more simple, and also we consider the price because we bought the kits, so the price is a key aspect. And this one we can easily use with, as I said, it's open source, so with Python. If the schools don't have license to MATLAB or Simulink, we right now are using both with Python, and more recently we are using MATLAB Simulink. Mainly because of the programming. Python demands more programming skills. Simulink is easier because it's more visual, so we are like the future work, I guess.
Is this on the electronics?
This is on this paper is mechanical engineering masters. Last semester we did this study in the physics engineering and in control theory. I think the next semester we'll do it.
On electronics?
It's electronics, physics engineering. Also they have control theory. So some mechanical, mechatronics, electronics, physics engineering. They all have like some sort of control theory.
You look like you are escaping from programming. And programming is a big problem almost everywhere.
Yeah, but for example, in industrial electronics, we have several subjects for programming. So I think it's okay to apply Python but for example, mechanical engineering, I think they only have one subject of programming. And physics engineering that I was teaching last semester, they also had one subject only. So when I asked if you prefer Python or MATLAB Simulink, they were like, maybe Simulink.
Yeah, because I do teach Python at the law school. So lawyers nowadays on the degree and on the masters, they already have Python. So engineers should be very comfortable with Python.
I agree, but it's not always what we see.
Can I just make a short comment? So please steer away from Raspberry Pis. I'll talk to you if you are interested. So I do have a PC lab at home. I did use it. So it is very nice because it fits a pocket. So it's really nice and it's inexpensive enough. the main thing about it is that you can almost forget the flavor of programming and just delve into the implementation details and think about discrete control, which is something that you might most often find confusing in Simulink. Okay? So the thing is that you can use it at several levels. Okay? So this is a very interesting presentation about real world interesting thing that people can really use and get into touch with the real labs. Okay, thank you.
Thank you.
Thank you.
Our next speaker, so I'm going to present the future challenge for the new education. Voice of students will be teacher trainers.
Hello everyone. I'm here presenting a work in progress, so it's part of the project. We're collecting the second phase of that collection. I have here my 3 co-authors, some of them. We have a lot of co-authors here because they are members of this project. And we are, I'm going to talk a little bit about the context. And so, nowadays we see that engineering education is just in the spotlight regarding the answers that can provide enhancing innovation and creative solutions to very complex problems. Where we can name green transition, the problems regarding energy, and some economic growth supported by innovation. So we're talking about this and some political pressure regarding this. And in many times we are asked of what is the profile of the engineer professional and how is supposed this engineer to perform several roles, most of the time implementing these kind of solutions and working with very diverse and multidisciplinary teams. So in most cases what we are talking about is if the training, if the education that higher education institutions are providing is really capable of giving these skills or providing these competencies for them to, in a way, perform these different roles. So, thinking about this, we submitted a project to our National Science Foundation, and the idea was to collect different voices and perspectives regarding this matter, regarding what is supposed to be, what is the desirable curriculum engineer. And we were thinking about the different kinds, areas of engineer, but directly what is the societal expectations and needs, and also about what higher educations are committed to do, and the compromise between these two tensions, because it doesn't have to be all alignment, but some kind of alignment. I think it's very important. Okay. In this project, we considered different data collection. We started to collect data from key stakeholders, people really interested in this field of engineering education. And then we collected data from interviews with students, teachers, alumni or former students that are now professional in the field, and employers. And it was this idea to see what was supposed to be in the curriculum, like formal, informal, what is the expectation about the professional at the end of each cycle, both at the first and the second cycle, and what are the higher education, Portuguese higher education doing, and what are the challenges, difficulties, and the strengths they are providing to this training and education. So, in this first phase, we collected data regarding we are going to have the quantitative data collection phase. So in this first phase, we wanted to collect a lot of impressions and perspectives. So we choose two engineers. One mechanical engineer, a more classic engineer, and a well-known field of engineer, and a new one, a biomedical engineer that is now implementing, but it has like this, it's very trendy. So a lot of people are, we have a lot of candidates in this field, and also the grades are very high, so it sounded like a good way to collect data. And we collect data from teachers with different positions and different roles, and students from both those courses, alumni and employers, and the employers were from big companies to small companies, and it's very, very funny because it's very different, not only in the field they work, but also in the dimension of the companies. Also, we choose 3 institutions. We choose University of Aveiro, because it's our home, and we choose Instituto Superior Técnico, which is, I don't know if there, I was looking for a name in English, so Technical Institute of Engineering from Lisbon and Instituto Politécnico do Porto. So it's 3 different, I think 3 very different institutions, even regarding their perspectives. So we wanted, it's a little bit more broad than we are taking here, but it's mostly the interviews and the focus groups have the following research questions wanted to respond to this. So if the current engineer colleagues are responding to the demands of society, what are the different perspectives, to acknowledge the perception about the profession and the profile they think it work in two dimensions. What the profile should be that is demanded by society, so what is the expected, and what is the profile that they think higher education institutions are providing. So, and then to identify the challenges posed to engineer and the job market, and if they are aligned with what the curriculums are offering, and to reflect on what could be possible paths and possible changes or adjustments to the curriculum. So, I'm bringing a little bit about the different perspectives, but I want to highlight 3 or 4 topics. For once, they are all talking about the same thing. So if you are going to ask, oh, are soft skills important? Yes, they are. Technical skills too. So it's important to have more relation with the labor market and what are works really happening. So everything is more or less similar between these groups. The focus is different, and I think it's in these little details that it's funny. For instance, soft skills are supposed to be developed in formal or informal activities, and for some people, soft skills are to be developed in voluntary activities. Because we don't have enough time, so technical skills are very important, and we have to focus this because an engineer has to know mathematics, physics, and whatever, so soft skills are like this. And it's strange because, but even students, it's not only teachers that are saying that. Some students say, oh, it really depends on the institutions and what type of approach they are more used to. So for some students, they say, okay, a student has to know what is going to be important for them, so they must enroll in this kind of activities. Because, you see, if we are going to have a unit curriculum and they're talking about communication, teamwork, this is just blah, blah, blah. and it's not really hands-on. And it's very funny because it depends on the real knowledge people have of integrating these technical and soft skills within the curriculum needs. I'm going to try to finalize. So everyone is very worried about program skills, and this is very it occurs with all the groups, but for teachers, having the skills to program is more important than knowing specific language. And students, employers, and alumni are very interested in specific language. We have to know this and this language. This is very important. Also, employers are very, very concerned about the applicability of the research. So they have to have research skills, yes, but research skills that can be very put hands-on and have like this real value to the market. This is very important for small companies. Like big companies, they go there, they do their kind of training, and so they are more concerned about technical skills. And so I think the funny thing here is if we go to buzzwords or buzz concepts, it's going to be much the same. But if you go to the specificity, they have different perspectives, and it's more or less aligned. And sometimes people have to experience different things to acknowledge that change is possible. So we have this. Engineering education is now facing challenges and opportunities that allows for further reflection and discussion on future paths and assumptions. So I think this is a very good moment, and there are different experience and different activities that can be brought to this discussion. On the other side, there's a lot of conflict between what is really to put on the curriculum that is time consuming, because if you put one thing, you have to take out other things, so we have to make choices. Thank you.
Congratulations for your team. One question that I have referred to a kind of job of engineering. You can engineer and work at private companies. I think it's the priority of his work. I suppose, but the engineering could be work at the public sector, at the university as a teacher, at as a small entrepreneur. I don't know, empreendedor.
Yes,
You can open a job in your house doing design for different companies, have a startup. How the team thinking about this situation of different kinds of professional environment of engineering?
Yes, we try to map some different kind of employers to have these different perspectives, but in a way we were kind of concerned about having this profile. And when we talk with people and the students, I think students are very concerned about this. They want us to solve problems, so they want us to have skills. They are very fast on taking decisions, having the capacity to gather technical knowledge, even though that sometimes they do not have it. So, thinking about the profile and not the specific job requirements, but we have different employers in our sample, and we hope that when we have the quantitative data, we can expand this employer's perspective also. But it's regardless of what they are going to do, I think most of the interviewers were very focus on this idea of having people with a lot of skills in problem solving and the ability to put together these soft and technical skills in order to work in effective solutions.
Okay, thank you.
Just one comment. My experience with soft skills, and I have some experience with soft skills, is that there's no point on discussing soft skills with professors, university professors, without soft skills. Okay? So there's no point. They don't understand. Okay? And nowadays, soft skills, I think, they are extremely important for engineering. And for example, I had a colleague that was the CEO of a big Portuguese company that I will not name. And he always said that we do have time to teach our employees. We don't have time to change the attitude of our employees. So soft skills are extremely important. The big problem in university is that when you have a course of soft skills, you have to take out a course of something. And that's the big problem, because everyone believes that what they teach is extremely important. And those guys from soft skills come with a new course that nobody knows what it is, they don't understand, they don't want it. But I do believe that it's extremely important for them.
Yes, it is true, but I think also some criticism about the curriculum units specific for soft skills are to be accounted, because if you go to a curriculum unity and you are talking about communication is this, and you don't do any exercise of communication, if you go and you see teamwork, you have to follow this rule book, and then you do like a reflection, an individual reflection on that. So I think we have to think about soft skills and technical things linked together, and maybe think about the pedagogical strategies to accomplish. But it's funny because it really depends, the need or the request for this depends on the profile of teachers and of students too. Some students are more reluctant on developing this, so sometimes it's funny to see. I was expecting like students wanted to have this, but not.
No, because soft skills mean communication, some people don't like to talk in public, and so on and so on.
Yeah, but since I was not their teacher, I thought, oh, they are going to tell me this is important. Even though if I was there teaching them, they would not want it. But they were, oh, okay, we have to learn this. We have some time to think about this. If you want, we can do some voluntary work. Sorry, I'm thinking a lot of stuff.
Okay, thank you. We have time for one question. If you want to ask Claudia, so it can.
I can speak
you like the students that you interviewed were from like the final years of the masters, from the bachelors? Was there any difference? Was it?
Yeah, it was students from bachelor and master, but not first year students.
Okay.
Only students who had at least 1 year in the university. And yes, it is different. That didn't have time, but master students are have a wider view, and most of the time they are excusing the lack of some training in the first cycle with some curriculum unities they are experienced that, and some other options. So they have, but they are more worried about this not having this perspective about what they are going to encounter when they are going to companies, when they are going to work. So that's their main concern is, well, we're really not prepared, we didn't have any experience there. Yeah. And bachelor students are more on, so a lot of things, but I'm not really being prepared for anything. So I'm a real bit overwhelmed.
Yeah. What we were actually discussing here was the fact that if these soft skills would be integrated into the courses themselves, so through group projects or debates or something like that, instead of just a course on communication skills, would be even more.
I like this idea. You have that when you have the like project-based learning, challenge-based learning, and all this, because you have to integrate this. But I think you have to be it's not just integrating. You have to assess this. You have to guarantee that they know how to develop the skills.
Just like we put a quick comment, we have been there, we did that, it also doesn't work. The answer is both. You cannot escape that.
Shorter, so, as to be able to present you, transferable skills matter for engineering students. Yes.
Okay, good afternoon to all. I did this work with my colleagues Soraya Oliveira e Carla Carvalho. I'm a psychologist, but I teach in the Faculty of Science and Technology from University of Coimbra. What I will talk about today, I will make the introduction, then I will talk about the methodology, then the results and discussion, and finally the conclusion. So, as we know, successive social, political and economic change and globalization transform the labor world. We know the labor world today is highly competitive. But in the organizations that require engineers, lots of engineers. But in addition to the technical skills, they also possess a set of transferable skills that distinguish themselves as a unique, because it's a world very competitive. Transferable skills, what are? Transferable skills regard individual characteristics such as personality, attitudes, and behaviors. They are crucial to individuals' development by combining inter- and interpersonal characteristics and attributes. And why transferable skills are so important? Because they promote self-efficacy, improves work performance, helps in the well-being and success of organizations by overcoming difficulties, and helps to achieve goals and complete tasks. For this reason, the engineering education community has been addressing the transferable skills relevance engineering course. Efforts have been undertaken around the world, but it's a big but, we need to know more about this subject. This study has two main goals. To analyze is the first and determine how important engineering students consider transferable skills for their future career. And second, to validate generic skills perceptions questionnaire at the level of importance for the Portuguese context. The methods. The sample, a non-random sample of 2019 engineering students from a Portuguese university in Portugal voluntarily participated in the study. More descriptive, the sample, they are 151 are male and 68 female from the following engineering course: mechanical, physics, civil, electrical and computer, chemistry and environment. Measures. The generic competence perception questionnaire was used. It is a self-report instrument formed by two sections. The first with socio-demographic data such as sex, academic year, age, course attended, nationality, native language, and the second with a list of 35 transferable skills in which participants indicate how important they are for their future career, using a 5-point Likert scale between 1 very important to 5 very important. Noted that skills, the transferable skills, are grouped into 8 dimensions: critical thinking, self-management skills, information and communication literacy, professional effectiveness, leadership skills, community citizens knowledge, interpersonal skills, and academic and problem-solving skills. Procedures. The instrument used was translate, adapt, and validate for the Portuguese population. Data were collected online using the Line survey platform. It is worth noting that the study applied the current ethical and deontological principles of research with humans. Data analysis. For the first goal, we use descriptive statistics for individual item scores of the importance level of transferable skills were analyzed to establish a general idea of student self-assessment rating patterns. For the second goal, a confirmatory factor analysis. We used the SPSS and the AMOS. Results and discussion. In respect to the first goal, to analyze and determine how important engineering students consider transferable skills for their future career, the skills considered most important generally and in both sexes are understand and respect other professionals, be open-minded and work together and listen to others' opinion. The skills perceived as least important was be aware of political issues, use of engineering equipment, design assessment, component or process. By sex, the most important are the same than generic, but they are different in the least important. By females are be aware of political issues, use engineering equipment, possess IT skills. While for males, they are be aware of political issues, design a system component or process, generate new ideas, and persuade others. As discussion, engineering students seems to consider that the most important transferable skills for their professional future at interpersonal levels, like communication, working teams, collaboration, leadership, coordination, etc. Engineering students seems to consider the least important transferable skills for their professional future at the community and citizenship, knowledge, academic and problem solver, and critical thinking skills level. But we know that skills are vital for active citizenship in democratic societies. Regarding academic and problem-solving skills, engineering students may consider them amongst the least important transferable skills, as they are an absolutely necessary aspect of their academic technical skills, like computer programming, software and hardware development. Critical thinking skills are not considered very relevant for males, possible because they tend to be more systemizing than females. Skill persuade others lies at the interpersonal level, makes perceive it as one of the least important skills. For the second goal, translation, adaptation and validation of the GSP key scale, we did a CFA, first order and then a second order because the majority of correlations were moderate and high. Conclusions. Engineering students of this Portuguese university needs to learn and develop transferable skills through their engineering course, mainly at interpersonal skills level. Second, improving transferable skills in engineering course demand that curricular unit is essential for a highly competent and successful engineer should be restructured. Third, this requires gathering technical and transferable skills by applying a variety of teaching and learning approach, namely problem, game, and simulation-based learning, as well as through e-learning applications. Similarly, technological tools can be used to support skill assessment. And finally, regarding the validation of the GSP key scale, level of importance, the instrument has shown good psychometric qualities. From an instrument perspective, the present work confirms a valid scale that can be used in future research. Limitations of this study. It is not possible to precisely establish the variables relationship as the non-experimental nature methodology used does not allow it. This study cross-sectional nature does not consider the dynamic aspects of variables involved. A convenience or accessibility sample method was used to select the sample study. The results were obtained only from one Portuguese university, and then extrapolation should be made carefully. 5. Only students, one information source, were used in the data collection, potential leading to a common variation of the method. And finally, 6. Perceptual measures variables were used. Further research, including additional variables like individual, group, and organizational ones, for example, using different methods like cluster analysis, testing the results found in this study with other higher education institutions, conducting, for example, longitudinal studies or case studies to monitor the progression of transferable skills. Here is the some reference and questions or comments. And
Thank
thanks
you.
for everything.
Yes.
Just a quick comment. Congratulations for the presentation and your work. You use the expression simulation-based learning.
Yes.
The word simulation has a specific understanding in engineering. We come from psychology or education science, where the term role-playing would be more adequate. But if not, simulation is, in psychology you have simulation labs, where you try to enact a certain situation. Simulation engineering is very much connected to computer modeling, etc. Just a comment.
Yes, but I think simulation in this case is the same that engineers understand. We need to know to work in some context, and we try to simulate that with, for example, with new technologies. So, or from virtual reality. It's the same. Role play, we can to reproduce and context with each other. I know it was clear or not. More or less. More or less. But simulation for us here is using the same term that an engineer uses. For example, with the research like virtual reality, there's some simulations. Okay? Role play is doing at class, for example.
Can I
Yes, you
help
can.
or
Help.
You are an expert in
of
this.
course? But I think that in this case, it in virtual context, maybe. I think it's more general than the application of orientation. I know it's more general. Maybe I can.
Yeah. You need to go into the specifics of what you understand by simulation. For instance, you can simulate a factory environment, factory
Yes.
plant, and you simulate a situation where there is an hazard and a machine does something, and you test the emergency procedures of that.
Yes.
You simulate a situation, and that's not role playing. So
Play.
you are right. Yeah, as long as it's playing.
Did you try to ask alumni, for example, that are already working, what was the importance of the transferable skills for them to get a job?
It was very interesting, your suggestion, but not in this study, no.
But I would like
It is
to,
very important,
I would
yes.
like to know, for those who got the job, how important soft skills were for them. Because to ask someone how they will be important, they don't know.
For example, I teach in the University of Coimbra at more or less 14 years. And what I see is I have lots of emails of engineers to ask me to help, for example, in work teams. Or yes. So they use, and I will do, my intention is to some congress or some, to explain what to the future engineers the importance of the transferable skills. Yes, it's very important.
Okay. First of all, thank you for your presentation. I took some pictures because it gives some highlight for us. We at the University of Aveiro, from 2 years by now, we have all bachelor courses on engineering has 2 curricular units on the transferable skills. First semester soft skills, second semester more technical, although soft skills. And these are mandatory courses on all engineering, bachelor engineering degrees. What we see is typically the students don't perception these opportunities at the same level as the more conventional classical curricular units. So we typically have a higher level of absence to the classes or not so much interest as we would expect from these topics. Do you have any insight on these conversations and these inquiries about what could be the reason for something that in theory it completely makes sense and we believe on that, but in reality might get a second level of interest from the main actors in this process, which are the students?
It is a very interesting question. I teach one monity in University of Coimbra for engineers. It's the same, I think, that you have in University of Aveiro. And my experience tell me that it's a challenge, a big challenge, because we have just, for example, in my case, I have 4 trimesters, and it's a few time for what they need to learn about soft skills. So my way of doing that is to talk about the importance of ethics, communication, and leadership. Okay, and work teams sometimes. But it is very different. I try to not do or explain to the students in a theoretical way. For example, in communication, they need to. I teach the way they should be presented in engineer. For example, very slides with some graphics, with very much tables, and I teach them how they should present this for an audience, for example. They need to be very practical. And the experience of the 2 years, only 2 years that I have, the evaluation of this unity was very high. But they are very interesting, but no, they are class, they are, it's not voluntary. They need to go, because I don't know if I have the same quantity of students if it's voluntary. Yes, it's a challenge.
Thank you. Because we are late, we don't have coffee break, we don't have coffee break. So,
Our session will be in the other room, and we have some problem because our colleague has the ambulance scheduled for 4:45. That's why I was going to finish this session. It's not going to begin to start off and now we are going to have the coffee break at 5 o'clock.